Hello and welcome to PCB Chat, where we talk with experts across the printed circuit design, manufacturing, and electronic supply chain fields. I'm Mike Buto, president of PCEA. Today's guest is Matthias Wagner. Matthias is chief executive and co-founder of Flux. Flux is a maker of an agentic AI-based PCB design platform and programmable simulator that runs in a browser environment. Regular listeners may remember that we've spoken with Matthias a few times in the past, most recently in February of 2024. Welcome back to PCB Chat, Matthias.
Thank you, Mike, and thanks for having me on the show. Very excited to talk today.
Since we last spoke, Flux has built out its platform with a variety of tools for design planning, parts searching, netlist generation, design review, firmware coding, and testing and debugging, just to name a few. A lot of this is built around your signature AI-powered hardware design assistant called Flux Copilot. Copilot uses a large language model that the company's engineers have trained and integrated into its design tool. LLMs, of course, are in widespread use to write code. I mean, look at how many computer science majors are out of work right now. But I think you'll agree that PCB design is a different animal. So how would you describe the obstacles to getting a tool to correctly and efficiently design boards? And what has Flux done to overcome those?
Yeah, it's a great question. I mean, I think for starters, right, these large language models, as the name implies, right, they deal well with language, even though they're multimodal these days. So, but they inherently deal well with writing something like code, because code is written language, right? And if you want to leverage these models to design a schematic or PCB board, right? So there's an extra obstacle here already, right? To translate for the model or make these models multimodal. That said, these models being able to talk to you and reason like a human is a huge advantage, right? Because if you think about previous approaches here to take machine learning models or AI models, right? It was fairly difficult for humans to interact with them and steer them, right? You had very abstract, call them knobs and dials. And the advantage of these large language models is that you can actually just talk to them, right? They can explain to you what they did, why they did it, and you can explain to them why you want it a different way. And then that way they can also learn from you, right? And I think that's an important piece here that's been missing in previous technology innovations here about machine learning. That, first, in electronics, there's an incredibly broad field with incredible depth of domain knowledge for each of these subcategories you might be in. And the other thing is personalization, right? There's no two engineers in the world who will fully agree on how to solve a given problem, right? Everybody has different experience. Your team might have different requirements. Your company might have different requirements. And so, but it's impossible as a company like us here to offer an off-the-shelf model that will make everyone happy, right? And create a schematic or a layout just like you would have done it yourself, right? And so that's where personalization comes in, and we make that very seamless, right? As you ask the agent to make corrections or make corrections yourself, that flows back into the model, and the model learns from that. And that model can be spread not just across your current project or future projects, but also across your team and organization.
Let's talk a little bit about how that teaching takes place. Is it all driven by the prompts that the user gives the tool? And by the way that the user then follows up with additional prompts, the LLM then determines, hey, look, this is really what the output that they're seeking? Or can you train the model outside of your seeking of a particular result? Can you add those constraints or that information just in general to the model?
Yeah, good question. I mean, so you can do it as you go. And I think that's probably the most effective way to do it, right? Because I think what we find is that most humans, if you just ask me now about all my little personal rules on how I make decisions, I can't list them to you. But as I encounter examples, I'll have them right there for you, right? And so I think we found that to be the most effective way. But look, of course, you can always think of at least a high-level list of how you want work to get done. And that you can just provide in something like a product brief.
Become a PCEA member today and gain access to a wide array of webinars, technical content, and our Discord server. Individual membership is free. Visit pcea.net/membership for details.
talk a little bit more about the human aspect of this. One of the things that struck me of late is how you've made it possible to use simple language to prompt the AI to perform functions up to full product design, if I'm understanding it correctly. Can you describe the full extent of the information needed to prompt the platform to generate a manufacturable electronics device or system? I mean, it's got to be extensive, right?
Yeah, good question. So, I mean, I think for starters, right, the way we market the product today is that we're selling an AI hardware engineer, but it's an intern, right? So I think, it like on day one coming onto your team, right, or onto your job site and performing at your level or above, right? We're not there yet, right? So I think it's more like an intern today, and then as you take it by the hand, go through example projects or tasks, right, to ever larger thing, and teach us again the way you want things to be done in your domain, right? I think that's the way for it to level up bit by bit, right? So that's I think is a good model to think about it. Then how it can go from a simple prompt to like a fully designed board. I mean, look, I think if you just tell it, look, I want a motor controller, that's fairly generic. And it'll design you a motor controller, but it'll just make a lot of assumptions along the way. And it'll probably not be a workable solution for you, because you probably have a specific motor in mind, specific constraints and stuff like that, right? Maybe you're like this for an aerospace application, right? And so I think the more of that contextual information you provide, the more likely it is that at the end you're going to get what you wanted.
So I love that analogy of how it's sort of at the intern level right now. Of course, it can take decades to get to expert in real time. So can multiple users use their same version of Copilot to accelerate that rate from intern to expert?
Absolutely, right. That's one of the big advantages. Like your whole organization can do that, and everybody can map their lessons learned into the system, and then you have an ability to centrally manage that knowledge, right, and curate that. But yeah, it can absolutely accelerate. And obviously, the other advantages, right? Look, I once was a human intern, right? I know what it's like. But as humans, we don't recall information as well as an AI model does, right? So an AI model, typically once you tell it once, or maybe give it 2-3 different examples, then it gets it. And so I think the learning rate is much faster here.
Now, of course, much of design is constrained by what's possible at the manufacturing level, both in terms of capability and also in terms of the yield, right? So to what extent can the fabricator or assembler then export their lessons learned or their constraints, their DFM rules, back upstream into Copilot?
Yeah, that's a really great question, and that's something we think about a lot. So, look, how it works today is a little bit manual. You'll send your design to your fab house. They'll come back with a list of things to change, and then you'll make those changes, and the model will learn from that. I think in the future, where we want to take this is that we want, integrate a little bit deeper with the popular fab houses, right, to have that information flow automatically back into the model, right? So that ideally the model will never make the same mistake for a given manufacturer or all manufacturers, right? I think there's always generic knowledge, and then there's knowledge specific to that fab house of what they can do or can't do or don't like to do, or what they charge extra for, and all these things.
One of the sayings, right, is a picture tells 1,000 words. And about 18 months ago, you added vision capability where a user could upload photos of images such as block diagrams to Copilot, which would then recommend parts for design. And believe me, I would much rather be able to upload an image of a block diagram than try to describe it in words, right? So where does that feature stand today? And who trains it to stay on top of all the various packages and part numbers?
Yeah, good question. I mean, so I think, in terms of image recognition, there's been great progress in the meantime. I think we have use cases now where even think about debugging use cases, right? You're measuring a pin somewhere, you have the wrong signal arriving here, right? You just can take a screenshot of your oscilloscope and provide that to the model and be like, look, here's what I measured at, pin so-and-so on this component when the circuit was in this state. Help me debug this. And the model can actually see that and then help you debug that, right? So there's tons of great use cases around the vision capabilities of the model. And then if you take that further now to the latest features we shipped, right? We took Flux from like being able to solve tasks for you to solve problems, right? And one of these problems includes placement, right? And so here we use the vision capability because what we provide the model is the actual image of what the layout looks like and what each layer looks like, right? To then make decisions on how to place things. So, there's like a ton of ongoing use cases. And how we improve that? Well, there's a combination of things, right? I think on one side is like a lot of this goes into like, preparing the data so it's easier for the model to consume it, right? Or the image model here specifically. And then over to also like, recognizing that there's different types of image recognition methods and models out there with different specializations. And then just essentially have a router that decides, hey, look, we're going to use this model for this task here.
Years ago, I sat in a talk by Dr. Neil Gershenfeld, who was a professor, he still is actually a professor at MIT. Now, he's part engineer, part futurist. And Dr. Gershenfeld laid out this vision of a future in which every product had an effective run rate of 1. In other words, any person who envisioned a product would be able to design and build it right on their desktop. Now, that was 30 years ago. But as I understand your grand vision on customization, what Gershenfeld envisioned, you're actually trying to put into practice that anyone could use Flux to make just about anything.
Yeah, absolutely. I think the man was spot on, right? I think, right, if you look at today, you can go to ChatGPT, right? And it will, from a prompt that you provide, create you a poem. And we think that, we're going to enable people to go from a prompt to a manufactured piece of hardware, right? And I think what's interesting here is that if creating the design is virtually free, because an AI model did it for you, right? Then what you end up paying is just really material costs, right? And then any product that's in your life suddenly costs like 1/5, 1/10 of what you paid for it, right? And so I think that's going to change a lot of things. And that might even be the end of the OEM model as we know it, because we have been all grown up in a world where we've got taught only if you mass manufacture things can they become cheap enough for consumers to afford. And I think that might change in the future, because why would you spend 4 hours browsing Amazon if you could have just described what you wanted and it got made for you and delivered to you in a week?
It does beg the question, though. You mentioned ChatGPT, right? So ChatGPT, Claude, some of these other tools that are out there. Why would I use Flux if I could just use one of those tools that might not be electronics or hardware specific? But if I understood how to describe the nature of the problem I'm trying to solve to one of those other models, why not just go that route?
I mean, I think, look, it's very simple. I think, if you think about the use cases that ChatGPT is optimized for, right, it's typically digital use cases, right? It's like create a digital output, typically text or images, right? I think they're expanding now to integrate with other software, right? And I think that's the right step. But if you think about hardware here, really, we're trying to turn bits into atoms, right? And neither Anthropic nor OpenAI is focused on that, for that matter, right? And I think it's it's very own domain with its very own challenges. And so that's why I think what we're going to see here is many different domain-specific implementations of these AI models. I do think that ChatGPT definitely captures the everyman's needs for chat agent, right? But think about for example, customer support. A big company isn't going to hire ChatGPT to deal with its customer support. You're going to go to a specialized provider who provides AI models and AI systems specialized for customer support. And so I think it's the same with us here. Right? We're specializing on turning bits to atoms, right? And that's our expertise, and that's where we go deep.
So the last time we spoke, one of the hurdles that the Flux platform was trying to overcome was limits on placement and routing and pin counts. What are the upper limits today?
I would say that in general, right, with the AI capabilities, if you think about the autonomous capabilities, you can probably anything from low to mid complexity you can do today. And you can probably do even high complexity things if you break them into pieces, right? So if you go in and say, look, design me an iPhone, that's probably going to be trouble. But if you break this problem into pieces with the AI agent, right, and tackle this. Okay, look, let's think about power system. Let's think about wireless. Let's think about compute. Then I think you can get there. And so I think, right, if you zoom out here a little bit, right, I think there will always be use cases where like you can go from prompt to finished solution today, right? And then there will be cases where like you can get 80% there, or 70% there, or 90% there, right? And our job, of course, is to like close that gap over time. But I think that's how I would think about it.
Now, I'm a firm believer that the future of electronics design is going to come from outside of the traditional industry. That people need to come from the outside to disrupt our industry, much in the same way that, say, Elon Musk disrupted the car industry. And the reason why I believe that is because it's just too difficult to break from the legacy products where you're just building off of what you already have and rethink what that's going to look like, and then take the risk that you're going to turn off those giant revenue streams in favor of something else. So I know that you feel you have some thoughts on hardware's needed revolution and how to get it going. Can you share those with us?
Yeah. I mean, first of all, I think it's a good observation, right? And I think it's like it's the innovator's dilemma here, right? The incumbents who've been delivering EDA software for decades aren't going to deliver an AI hardware engineer because it takes a very different mindset and culture and risk appetite, as you point out, right? Look, we believe hardware shouldn't be hard, right? We believe that's like a self-serving and self-imposed constraint that the industry put on them, right? That they were like, no, hardware's hard, and let's not try to make it easier, right? We believe that ultimately anyone in the world will use these kind of tools where you can go from a prompt to a finished product, right? We're seeing that now with like text-based outputs like in ChatGPT, and here we're coming to do this for hardware, for electronics first. We're going to expand to enclosures from there to get them packaged until you have like a finished product on your desk, right? And that's how we think about that. We think this should be easy, and we think everybody should be able to do it, right? And look, I would have sounded delusional 20 years ago when I said that, right? Because the whole supply chain wasn't there. Making custom electronics was something for big companies, right? Mid-sized companies couldn't do that, yada, yada. But look, the supply chain is here available. Anyone in the world at any budget can get custom electronics made in China. If you can design it for $50, right, you can get them made. And that's a fundamental shift change, right? And then we are like essentially just ushering in the last step of this democratization. It's already been happening, right? Which is like, to reduce the cost of the design to virtually zero.
Right. I mean, there's a lot of that I agree with. Certainly, on the latter point about the manufacturing side, where if you don't have prototype companies or say, desktop printed electronic devices that are low cost enough for everybody to purchase and use, it's hard to get from text-based or language-based design prompts to manufacturing, because manufacturing is the obstacle, right? That's the limiter. With regard to the legacy EDA companies, of course, many of them are going down the route of trying to build AI into their planning, their parts selection, supply chain management, and even routing and placement at varying degrees of success. I think they do recognize, because they're having those conversations with customers all the time, they do recognize that the industry is kind of pointing them in that direction. But I do think that it's very hard, when you are, a big publicly traded company and, maybe you do $100 million a quarter or more in revenue from your EDA tool, just on the PCB side. It's hard to conceive of a market where you might be selling these tools for a fraction. And by that, I mean, a fraction of what you're currently selling them for. We always talk about how, you're better off obsoleting your own products instead of waiting around for somebody else to obsolete them for you. But in practice, I think that's much more difficult to execute, right? So, that's where companies like Flux come in.
Yeah, totally, right? I think what's interesting here, right, if you zoom out here and go to the game theory level of all this, right? These companies are interestingly, let's move past just the cultural issues and risk averseness and moving quarter to quarter, and everybody just typically being worried about the next promotion, not about disrupting the industry, right? To win the AI game, you need a lot of data. You need to essentially have shown the model millions of edge cases and how to solve those, right? Like a good example is here how Tesla has been training their cars to drive themselves. But the way to do this is to have millions of cars on the streets every day and collect this training data and connect these like micro decisions that humans make across all these edge cases they encounter. And that then gets distilled into a model, right? And so similar here for EDA, it isn't enough, like I said earlier, to just write like a list of your design principles down, right? The model needs to observe actual engineers in the field across many millions of micro decisions to learn how to do a task itself, right? And the only way to do that is to have a cloud-based offering that allows you to collect this data as an EDA provider. And I think many of the legacy companies, right, they have like 10, 15 years fooled themselves into being like in the cloud now by switching to a subscription model, but have missed the actual technology shift that's happened here, right? And so they're not just behind on that now, they're also behind on being able to capture the training data they would need to ever deliver any model that does anything useful, right? And just delivering it to a single customer, even though that customer maybe has 20,000 engineers, that's just not enough, right? It's not enough data to train a model.
One of the interesting conversations I've had of late with some of the major EDA companies is whether in the age of AI, they might have to shift back from that time-based model to a permanent model. You're basically buying that license on a permanent basis again, because if you're relying on your customer to train their own AI, then the time-based thing might not really work for them really well. If all of a sudden it gets shut off, or there's a potential of getting it shut off after you've done all that training, and yet they might not really like being locked in forever to that particular tool as much as the EDA company might want them to be.
Yeah, it'll be interesting how this pans out, right? I think in software engineering, you have like this similar thing happening. It's like how is that going to get architected ultimately? It's going to be interesting. You know, another thing I was going to add is like that I think oftentimes people fool themselves. Also, they say, oh, but we have 30 years of historic schematics and PCB layouts here. And it's like, well, that's not so useful, right? You're not going to teach your intern who just joined by showing them finished products or designs, right? The way to learn is to do things. And that's true for humans, and it's as true for models. And so again, right, you need to like create environments where these models can watch humans do the job.
Right. And then that's really kind of what I'm getting at, is that it's impractical to dump an aerospace design from a Boeing jet from 40 years ago into your AI and use that as a pathway to go forward, rather. But the person who designed that may still be around. And that knowledge really is what you want to capture.
Absolutely, right? And I think it's a great tool for knowledge transfer in that way, right? For like the previous generation to pass on the knowledge to the next generation, right? I think it's an incredible tool for that. Yeah, and look, and we're like very much here day one of all this, right? This is going to be incredibly interesting to see and exciting to see over the next decade where the pieces fall here and how these systems actually get designed to capture this at scale and transfer knowledge at scale. But yeah, right, there's always these things like, look, we wouldn't know how to land on the moon today because we've forgotten how to do that, right? And that's exactly the thing you can prevent, right? If you use tools like Flux now, right? This knowledge gets stored, and in 100 years, you'll be able to recall exactly how we designed that board today.
So one of the questions that always comes up when I'm talking to AI-based startups is, well, how are they going to scale? Do they have an enterprise solution? But if I'm hearing you right, you're really kind of negating that whole argument by making this so user-friendly that enterprise really isn't the customer. It's, every individual, regardless of where they're at, what they're doing, you really just want those individual users. It doesn't, we don't really need to call them hobbyists because that's really not the right word. They can be professionals as well. But You don't need a top-down system to be able to implement this.
No, exactly. And that was one of the key insights, right? I mean, like, we're not the first ones who have tried to provide modern tooling for this industry. It's just that in the past, everybody thought the only way to sell is top-down. And what people fail to see is that, like, many of these organizations, like, they haven't bought new EDA software since the 80s. They don't even know how to evaluate or buy software, right? Because there's never been new software for them. They're also, like, they're incredibly risk averse. They're not software first people oftentimes, right? So, like, the sales cycle might easily be 6, 7, 8 years here for bigger organizations if they're ever going to buy anything new. Plus, you would have to first match what they have. You don't just have to match it in functionality. You will have to, like, outdo that in functionality, which is, like, that costs you hundreds of millions of dollars in R&D, right? Which is difficult to do for a new entrant. So we flipped the whole thing upside down and said, look, we're going to come up in with this AI first approach, and we're going to sell it to individuals. We can put this kind of tool now into the browser, right? So individuals don't have to install software anymore. You can be at any organization in the world and just use Flux. And you want to collaborate with a teammate or somebody on another team, you just send them the URL and they can collaborate with you, right? And that was the big insight. And look, that's worked for many other companies too. If you think about GitHub, Dropbox, Figma, right? It's like a path of success that we're, like, walking here. And so as a result, as I said, look, most of our customers are professionals, right? And many of them work at very large, consumer electronics, defense companies and whatnot. But they sign up individually, right? They swipe their corporate credit card and just use that. Sometimes whole teams will do that, where the managers are like, okay, look, guys, let's just switch here. And I think, look, clearly, right, we're not coming in today to replace the main tooling to design a MacBook at Apple, right? But we're coming in for small to mid-sized product lines, especially for all the, like, auxiliary teams that make the machines to make the machine, prototypes, right, that do R&D here. There we come in, right, and help them to just build what they need to build faster and cheaper, and frankly more fun, because it brings, like, this, like, agility that you have in software to electronics design, right? Where, like, you just have an idea on a Thursday night and you just put it together, and on Friday morning you demo to your team and you're up in production by midday. And that's the kind of agility we bring to, like, hardware teams now.
Technical challenges obviously are a big component to master, but you mentioned the risk aversion, and I imagine that is probably just as large of a hurdle for you. And I wonder whether, especially within the larger companies, whether it's more often that they're hearing about you and downloading the platform before you even realize that they're interested in it.
Yeah, it's definitely how it works. We don't have a sales team. We don't have any, like, outbound motion here to get to the market. It's like, no, people find us through Google search, through social media, and then they find us increasingly through tools like ChatGPT.
Okay, so that's pretty interesting. How many folks are on the Flux team now?
We got, like, around 20 working here, so it's a very small team.
Finally, I want to circle back to kind of the beginning. What's on your roadmap? I mean, what are you guys working on most diligently right now? What are the updates that we can expect over the next maybe 6 to 12 months?
Yeah, great question. Like I said, we just last week we launched the ability, right, to, like, go from solving tasks to solving problems. I think on some of these, right, the agent does really well. It delivers the solution on first try. On other ones, it gets you 70, 80% there, 90%, sometimes 50%, sometimes it fails. And so a lot of work is going in right now to close that gap, right? And increase the success rate across use cases. And then look beyond that, right? The other thing that we're excited about is, like, deeper integration with manufacturing, right? So that the agent can actually pull quotes, look up constraint at manufacturers, help consult the user which manufacturer to go with, right? But then also be part of the learning loop as things go into manufacturing, how to increase yield, how to improve automated assembly, how to write test scripts to test these boards on the manufacturing line, right? And all these kind of things.
Does that require any special conversations or data from those companies? Or is that something that can be almost kind of like standardized and implemented?
Yeah, we're trying to figure that out, right? I mean, I think what's interesting here is, like, that oftentimes the communication with the manufacturer today happens via email. and email is very comprehensible for a large language model.
Right. It's exactly what you're doing. Right. It's words.
Yeah. So we might just start there, right? To look at these emails, and extract the knowledge from there, and apply that to the design and then send a new revision out. So, I think that's going to be very exciting, right? And it goes just one step further down the value chain here.
Okay. Anything else you want to add before our conversation comes to a close?
Yeah, I would say this. Look, a lot of people come to Flux, right? Especially very senior people, and they think, oh, this is a toy. And I think what I would remind everybody of that any big change in humanity started as a toy, right? You think the company like Google or YouTube or Facebook, all these things started as toys. You think of Tesla, that started as like a small batch of like an enthusiast electric vehicle, right? Everything starts as a toy before it gets big. And just embrace that. Come to us, give it a shot. And look, we might not be ready to tackle your workloads today, but we will in the future, right? And we'll get there faster, if you stick with us and support us and provide feedback and be as relentless as we are to bring this future, the stream alive, right? Be as relentless in providing us feedback.
A wise man once told me, if you want to predict the future, watch your kids. The corollary to that is watch your kids and what they're playing with, right? Take a look at their toys.
Yeah, absolutely, right? So I think, look, I'm very excited here that we get to be part, right, at this new chapter for humanity, right, the dawn of AI here, and that we get to be the ones here in the front seat to like apply that to manufacturing and design, right, of hardware. And I invite everybody onto the boat. We want to make this happen. We're very determined here, and join us. Let's make this happen together.
Well, thank you, Matthias. Our guest today has been Matthias Wagner of Flux. Those who want to learn more can visit flux.ai. Thanks for joining us, and come back anytime, Matthias.
Will do. Thank you so much, Mike.
For PCB Chat, this is Mike Buteau. Have a nice day.